Okay, welcome to Geometry, Chapter 5, Section 6, Inequalities in Two Triangles. A very beautiful lesson for you today. And we're starting with a quiz. Pause the video and see what you can do. And come on in and say hello.
Silent mouse.
And the answer of writing angles from smallest to largest, Joey?
Is angle X, angle Z, angle Y.
Ta-da! And the lengths of the sides. Describe that for us, Blake.
3 must be less than n and n must be less than 21.
Or s is greater than 3 and s is it needs to be less than 21. Okay, very good. So today's objective is to apply inequalities in two triangles. So there are some interesting inequality relationships in triangles. So guess what the theorem is called? Inequalities in two triangles. Very good. So the I meant to keep that hidden. Oh well.
Do you just make up
The
your script as we go along?
theorem. The hinge theorem is a cool thing. What does a hinge look like? What do you think of?
Like
It opens and closes.
it's the chair thing. No, it's the chair.
It's the thing.
It's a door, like in a door.
It's the thing in the door. It's those metal things that
They
have like
turn.
two parts,
And they
right?
go like this.
Part of it is bolted on or screwed
It's
onto
able
the
to
door,
swing- it
the
goes
other
like
to the
this.
wall, right? And it goes like this.
It's like your SpongeBob thing.
Very good. Okay, so take a look at the hinge theorem. Take a look at it. It says that if two sides of one triangle are congruent to two sides of another, we can see that here. Side AB is congruent to side DE, and side AC is congruent to side DF. If two sides of one are congruent to two sides of another, and the included angle, remember the definition of included angle?
Yes.
It is the
Angle between the two sides.
angle
that
between the
we're
two
talking
named
about.
sides, right? If these two angles are not congruent, then the longer side, right, the longer third side is across from the larger included angle. So look at angle A here is larger than angle D. Therefore, side BC is longer than side EF. So imagine on a hinge, right, that the two sides are equivalent, congruent, right? And so if this angle between them is larger, then that opposite side must be longer. That's what the hinge theorem is saying. It makes total sense, doesn't it? Okay. The converse of the hinge theorem would be if we know that the opposite side of a triangle that is sharing two congruent sides with another triangle, right? If we know that the opposite side is longer, we can say something about the angle between those two sides. Or the way they say it here is if two sides of one triangle are congruent to two sides of another, and the third sides are not congruent, then the larger included angle is across from the longer third side. You get it? Okay? So, how do we use this? Example 1. We're asked to compare the measure of angle BAC and the measure of angle DAC. And the one thing that we learned on the last quiz was you really need to use your eraser or something and identify the correct angles. Sometimes you're answering the wrong question, right? Not often, but sometimes. So make sure you trace it over and you know what we're talking about. We're looking at measure BAC and measure DAC.
Wait, doesn't BC and DC, don't they have to be like congruent?
BC and DC are not the same length, but why are they of interest to us?
Because they are the hinge.
They are, aren't they opposite these angles?
Yes.
Right? They are opposite. And what can we say about the other sides that make up these angles? Like BAC is made up of a length of 4 and then a length of unknown, but it's a shared side with this other angle, right? AC and 4. So these are two triangles that have two sides that are congruent. And so because this angle here, BAC, is across from the longer side, what can we say about angle BAC? We can say it's larger based on the hinge theorem. The way that the key describes it is compare the lengths of the sides. So by the hinge theorem, by the converse, I'm sorry, because we're using the side to determine something about the angle. By the converse, we can say that the measurement of BAC is greater than the measurement of DAC. Okay, so let's try this. Let's compare EF and FG. When you don't see the little segment symbol on top, what are we finding here? What does EF represent?
The length.
The actual measurement of the length, right? So EF out here and FG. So we see, what do we know that is useful to us?
FH equals
That-
FH.
FH equals FH.
Well,
Okay.
and the angle on the other side must be bigger because it equals 180 because of the linear pair.
So Amaya is saying the angle FHG here, this unknown angle, is something we can find, right? Because it is a what?
Supplementary angle.
Supplementary angle or a linear pair with this EHF, right? So what is the measure of this angle here?
That would be 98.
98.
Whoa. I was faster than Joey in that.
Talk to the
Okay.
fast at this.
And because we can say that in this triangle, EFH, this side is congruent to this side, right?
Yeah.
That's given. And we know that this side is congruent to itself by what?
Reflexive
Reflective
property.
property of equality.
Okay, so what can we now say about side
FG is
EF
longer.
and FG?
FG is larger by the regular.
The hinge theorem.
Right. We're now using the angle to state something about the third side, so it is by the hinge theorem. So the way the key describes it is compare the sides and angles. And they did exactly what you mentioned, right? Find the missing angle. What do we call that angle that's between the two sides?
The
The,
what?
what do we call the angle that's between the two known sides?
Included.
Good. The included angle that was missing was 98 degrees. And so by the hinge theorem, we can say that EF is less than FG. Okay, so here we have, we're being asked to compare the measurement of EGH. Let's outline that, EGH. Okay, you might want to put a little angle symbol in there. We're comparing EGH with angle EGF. EGF, this second angle. Comparing those two. Okay? And so what do we know? Like,
That HG equals FG and EG equals EG.
these are congruent. So we have two included angles that we don't know the value of. But do we know something about the side opposite them?
EF is larger.
Good. EF is larger than EH. So EF is the side opposite angle this one, right? EGF. EGF. So what can we say about angle EGF?
Is greater than.
It must be greater than angle.
EGH.
Probably should put the measurement close, right? Okay. And what are we using to determine this?
Converse.
Converse of hinge theorem.
Converse of the hinge theorem. Good. So that's because we're using the known side, the known third side in that case.
Okay. You may see what I said. Okay. So, children, BC
They lied.
and AB. I'm being like, this is common sense or something. So, since this angle is larger than that angle, that means that this side is longer.
They can't see anything because of your
Right?
Okay, is this
So-
the hinge theorem or the converse of the hinge theorem?
I can be the hinge.
This is the hinge theorem because we're
So,
making a statement about a length
Since
of the side.
this one is longer than that one, that means that this side is bigger.
How can an angle be longer?
So, pretty sure that's not
The angle is not longer, the angle is larger.
Sorry.
Okay. BC
Segment.
is,
BC is longer
It's
than,
proving her good that she knows what longer is now.
yes.
AB.
AB.
So if you're really gonna, if you're really gonna make this as an inequality, would we use that segment symbol over the top of BC and AB?
No.
No, we would say BC is greater than
That's why I wrote longer.
AB without the segment symbol on top,
Your beautiful writing.
on the hinge theorem.
Maya, I'm pretty sure that blue line. you
Take a
drew is
bow,
south.
Amaya, take a bow. Like in the video, take a bow. You're recorded for all eternity now. Okay, John and Luke leave school at the same time. John rides his bike 3 blocks west and then 4 blocks north.
Don't they live at the same time?
Luke rides 4 blocks east and then 3 blocks at a bearing of north 10 degrees east. Who is farther from school?
Luke is.
Explain.
Because
So we might want to write some
the measurement.
Because the angle is larger.
some detail into this, right? Okay, so it looks like Luke, or John, I'm sorry, has gone at some point 3 blocks west and 4 blocks north. It looks like, I don't know if this is perfectly to scale, but it looks like we could put those there. And Luke has moved the same kind of blocks, right? 4 blocks east and 3 blocks at this bearing of whatever it is. So they do have an included angle between congruent sides, don't they? Here's one included angle, here's the other. The question is, which is greater?
This larger.
It looks like this is larger, which would lead us to believe that
That's longer,
Luke's
so that means he has to work harder.
distance is greater than John's.
Because it's 100 degrees, not 90 degrees. It's such a six here.
Would this be the hinge theorem or the converse of the hinge? Okay, so let's see what is stated. So the angle formed by John's is 90 degrees, is smaller than that formed by Luke's route of 100 degrees, so Luke is farther.
So would we
Okay.
have to use like a protractor for that or something?
We were just reviewing that, how do you find the 100 degrees versus the 90 degrees?
Wait, you're giving
If
me
we
the
go,
answer right
if
now.
John goes 3 blocks west and then 4 blocks north, you're traveling west and then north, you're making a 90-degree angle out of that, right? But Luke goes 4 blocks east and then he goes north, which would be 90, but 10 degrees east, you're adding 10 degrees to your 90 and you end up with 100. Okay, but we're almost out of time, so we don't have time to draw it. Let's go over one proving this, 1 2-column proof, and then you can do your quiz. So we know that AB is congruent to CD, it's given, and the measure of ABD, they're saying ABD here, is greater than CDB. Here, CDB. So we're out to prove that AB is greater
That
than
doesn't make any sense.
CB. Interesting.
But is this like an indirect?
Okay, so let's look at this. We know that AB and CD are congruent. What else do we know that would be interesting and useful?
BC is congruent to AB or the X parallel.
BD equals BD.
We don't know about anything being parallel, there's no statement, but we know that BD equals BD. I mean,
Yeah,
this is
BD
a
equals
shared
BD.
side. So we can take a look at this angle, ABD, and CDB, right? We don't know that they're same. As a matter of fact, we know that ABD is greater than this one, right? So if this is greater, what can we say about AD?
It's longer.
AD must be greater than what?
BC.
See, but they want us to say AB is greater than-
BC, that's based on the hinge theorem, right? But they want us to say AB
It's greater,
greater
than
than
CB, which doesn't make any
CB.
sense because it's not.
How would you know?
Because we
This is
cheated.
not drawn to scale.
It doesn't give us.
Well, what do we know about as triangles, angles? In this triangle, let's see, we're trying to prove AB is greater than CD. AB,
It's greater than CB.
Can't prove
It doesn't
for
even
sure.
look like that at all.
I think it's supposed to be 80 and they just.
did they make a?
They
Let me
biffed.
pause and see if they made a
Yeah,
mistake.
they might have said 8.
Okay,
Try again.
so the proof is actually
In the
the key that the book is providing, right? And look at what they're really out to prove. AD is greater than CB, which is what we just found.
Goes a lot.
Okay, so here are the steps that they went through. The question itself has the wrong question in it. This AB should be AD. This should be AD. Okay, so this is a D, AD here.
10 seconds.
Okay, and whoops, is it 10 seconds? No. Oh yeah, here are the answers.
2, 1.